Hello everyone, I am BUK working as an assistant professor of physics in Dr. BRR Government College, Jadcherla. So today we will start a new chapter which is digital electronics. Uh, in today's video we will be dealing the topics of the chapter digital electronics, which include the introduction and the different types of number systems that are present, and we also try to convert a decimal number into binary and a binary number into decimal, and those things we try to cover in today's video lesson. Okay, right. Let us move on to our next slide. So this slide includes the introduction of this chapter. So anyway, for convenience, let me take the marker now. So coming to the introduction, first of all we try to understand what is digital electronics, right? So digital electronics is a branch of electronics which deals with the generation, processing and storage of digital signals. So this is the basic definition of the digital electronics. So it's a branch of electronics which deals with the generation, processing and storage of digital signals. And it was first invented by George Boole. So he is the one, George Boole is the one who invented this, and the algebra which is used in this is called as Boolean algebra. Okay, so the algebra which is used in the digital electronics is called as Boolean algebra, and in this any information is represented in terms of zeros and ones. Okay, so in digital electronics any information is represented in terms of zeros and ones, and the zeros and ones we call any one of them. So that means the 0 or 1, so they are called as a bit. Okay, so you try to understand it. I hope this slide is the introduction part to this chapter digital electronics. So have a look at these things. So in this slide we understood the definition of digital electronics and how the information is stored, and the digits that we use to store the information, which we call them as bit, and who invented all those things are present in this slide. Okay, so let us move on to our next slide. So these are the different number of the different number systems that we have. So the first and the foremost one is the decimal system, which we are using in general. So the decimal system is the one which consists 10 digits from 0 to 9. So 10 itself tells you that means 10 represents this deci here. So decimal system is the one which consists 10 digits from 0 to 9. So this one, so this we call it as decimal system, that we are familiar. And the another number system is binary system. Binary means true, so please try to remember. So binary system consists only 2 digits which are 0 and 1. 0 to 1 means 0 and 1, you can say that. And octal system is the number system which has the basic digits of 8 which are from 0 to 7. So from 0 to 7 this system will have 8 basic digits. Okay, and then another one is hexadecimal system which has the basic digits or symbols from 0 to 9, and In general, in decimal system after 9 we will have 10, but here in case of hexadecimal system after 9 you will have capital A, capital B, capital C, capital D, capital E and capital F. That means from 0 to 9 you will have 10 digits and other extra 6. So that means in overall 16 basic digits will be present in hexadecimal systems. So these are the different types of number system we have, and whatever is there in the syllabus we try to study now, we try to understand them. Okay, so now coming to the first number system, which is a decimal system. Okay, anyway, before moving on to the different types of number system, there are certain terminology that you need to understand here, and we try to understand them. And for convenience, let us take the ink color to be something else. Say some red. We take some red. Okay. So anyway, now let us try to understand what is a number system. So in our previous slide, we came to know the different types of number systems that do exist, and in this slide we try to understand the basic definitions of the terminologies that we come across in this chapter. Okay, so the first one is number system. So what is a number system? So remember, the number system is a code which relates quantities and symbols, So in general we say that 1, 2, 3, so these are all quantities, right? 1 is represented with the symbol. Okay, so it's a code. Remember, number system is a code which relates quantities and symbols. That means how the quantities are represented with the symbols. Okay, so that code we call it as a number system. So different number systems have different symbols to represent the quantities, so that you have to understand here. So number system is a code, so please remember its definition. So number system is a code which relates quantities and symbols. And the next one is the base. What is base here? So it is the number of digits or basic symbols in the number system. I discussed this thing in our last slide while we were discussing the different types of number system. If you remember, while discussing the number system, for example, let us take decimal system. Decimal systems was having the digits from 0 to 9, right? So if you start counting from 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So that means in overall it was having 10 digits, 10 basic digits. So those basic digits we also called as basic symbols. So this the number of that basic symbol in a number system is called as base. So that you try to understand. That means in case of decimal system, it was having the basic symbols from 0 to 9, and hence its base becomes 10. So let me take a marker now. So 10 is the basic symbol, base of a decimal system. So remember, in case of decimal system, it was having the basic digits from 0 to 9. So even if you count 0, 0 also has to be counted, and hence from 0 to 9 overall 10 digits, basic digits will be there, and that number, that basic digits number is called as base here. Okay, similarly in case of binary, in binary system was having only 2 digits, one is 0 and another one is 1. So 0 and 1, in overall the basic symbols are 2, and hence the base of the binary number system is becomes 2. Similarly, the another number system that we saw was octal number system. So the octal number system was having the digits from 0 to 7. 0 to 7, that means 0, 1, 2, 3, 4, 5, 6, 7. Okay, 7. So in oral we were having 8 basic digits or symbols in case of octal system, and hence its base becomes 8. In similarly, in case of hexadecimal system, I already told you that it was having in oral 16 basic digits. So hexadecimal system, okay, so octal system was having the basic symbol of 8 basic symbols of 8, and hence its base was 8. But in case of hexadecimal system, the hexadecimal system was having the numbers, okay, basic digits or symbols were from 0 to 9, and the next A, B, C, D, E and F. So that means 0 to 9 becomes 10 digits, A, B, C, D, E, F becomes 6 digits. So that means in overall the hexadecimal system was having a basic symbols of 16, and hence its base we can say that is 16. And I hope you understood the definition of base. So remember, base is nothing but the number of digits or basic symbols. It is nothing but the number of digits or basic symbols in a number system. So different number systems will have different base. Okay, so decimal system will have 10, binary will have 2, octal will have 8, and hexadecimal will have 16 basic symbols, and that number is nothing but base here. Okay, now coming to our next definition, which is bit. So what is a bit? So it is an abbreviated short form of binary digits. So generally the computer students must be knowing this one. That means whatever the computer coding or language is represented in terms of zeros and bytes, and while studying about the memory of different systems, we study gigabytes, okay, megabytes, like that, right? So anyway, the short form of binary digits, that means either 0 or 1, we call it as the bit. Okay, so that you try to get it. It is an abbreviated or short form of binary digit. So that means either binary number systems do have only two basic symbols, one is 0 and another one is 1, and that 0 or 1 we call it as the short form of binary digit, and that short form 0 or 1 is called as bit. Okay, anyway, just for definition I have written here. So 1 byte will be equal to 8 bits, so that you just know it. There are other formulas too also in terms of gigabytes, megabytes and all those things. I am not writing all those, but here one definition I have written, so please try to remember it. So we can say that 1 byte is equal to 8 bits. Similarly, coming to the digit. So what is a digit? So it is the basic symbol used in a number system. Okay, so basic symbols. So we already try to understand what is a basic symbol or digit, right? So that means, for example, in case of decimal number system, 0 is written as like this. Okay, circle. It looks like a circle. That is 0, and 1 is nothing but a line. 2, how do we write? 3, how do we write? 4, how do we write? 5, how do we write? So how do we write? That is nothing but the symbol, right? Basic symbol, and that basic symbol is called as digit here. Okay, so it is the basic symbol used in a number system. Okay, so that we call it as a digit. For example, in case of binary system, you know that it has two digits, 0 and 1. This 0 and this 1 is called as a digit, basic symbol. Okay, so that you try to understand. Okay, in case of decimal system, there are other digits too. It has an overall 10 digits, 10 basic symbols: 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9, and like that. Okay, so anyway, so I hope this is clear. Digit is nothing but the basic symbol that we use in a number system, so that we call it as digit. So that means this is also over. It is nothing but the basic symbol, okay, that is used in system. So 0 is called as a digit now, and 1 is called as a digit again, so please check. And then next one, weight. So what is weight? So it refers to the decimal value of each digit position of a number. For example, if you take any example like 1, 2, 3, so there are 3 digits, right? It's a decimal number now. Let us assume that it's a decimal number. It has 3 digits now in this example: 1, 2, 3. So these are all the basic symbols, right? But depending on its position, its value is decided. That value is called as weight. So for example, 3 is in units position, and 2 is in tens position, and 1 is in hundreds position. So that means I can write it as 1 into 100 plus 2 into 10 plus 3 into 1. So that means though this 123, okay, which is a decimal number, it has 3 digits, right? But depending on the position of the digit, its value will be different, and that we call it as weight here. For example, this also can be written as 1 into 10 square, and this also can be written as 2 into 10 power 1, and this also can be written as 3 into 10 power 0. So that means we say that the 3 has units value. It is in units position, right? And 2 is in tens position, and hence its weight becomes 10. And 1 is in 100 position, and hence its weight becomes 100. So that you try to understand 100. So that means that 1, 10, 100. If there is one more digit here, for example, you take where is our marker? Let me take this one. Yeah, here it is. So if I take one more digit here, so what happens now? This 4 is in thousands position, and if I take one more one, it will be in 10,000s position, like that. Okay, so depending on the position of the digit, its weight will be different. So this weight we call it as the position value of the digit in the number, so that you try to understand. So that means depending on the position, the digits will have its own value, which we call it as weight. Okay, I hope it is clear to you. Now let us move on to the first number system, which is a decimal number system that we try to understand. Okay, so now coming to the decimal number system, it's our decimal number system. So it is developed by Aryans around 5th century. Okay, so as you already know that it contains 10 digits or basic symbol. What are they? 0, 1, 2, 3, 4 and 5 and 6 and 7 and 8 and 9. So overall how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So in overall it will be having 10 digits or 10 basic symbols. Okay, so since the number of basic symbols that are present in this system are 10, its base will be 10. So this base is also called as radix, which is 10. So remember, it contains 10 digits. What are they? From 0 to 9, and this number is called as base. So since the number of the basic symbols that are present in decimal number system is 10, its base we can say that is 10. And as we already discussed this example in our last slide, so the value of each digit in a number depends on its position, value or weight. Okay, so this example almost we discussed in our last slide. For example, if I take example 1 2 3 4, so how do we call this number? We call it as 1234. So if I expand it and write each digit in terms of its weight or in terms of its position value, how can I write it? I can write this, let us start from left side. So I can write 4 as 4 into 10 power 0 plus, I can write this 3 as 3 into 10 power 1 plus, and I can write this 2 as 2 into 10 square, and plus I can write this 1 as 1 into 10 to the power of 3. So that means this 1 into 10 power 3 will give you 1000. This becomes 1000, and this becomes 200, and this becomes 30, and this becomes 4. Okay, so if you add all these three, 4234. So this is what you get now. Okay, so this 1234 is a number, it's a basic number, sorry, it's a decimal number. It has 4 digits now, and depending on the position of those digits, their weight will be different. And what are these their weight? Their weights are represented in terms of 10 powers here, so please check it. Okay, either 10 power 1 or 10 power 0 and 10 power 2, 10 power 3, 10 power 4 and so on. Okay, so since the base of the decimal number system is 10, even the weight is represented or can be written in terms of 10 powers only. So please check it out. If you take a fraction also can be written as 10 power minus 1. Next digit will have a value of 10 power minus 2 and so on. So that you try to get it. So anyway, from this example, the weights of 1 2 3 4 I can write it as this is 1000. We write it as, how do we pronunciate? Itself gives the weight of those digits, so we pronunciate it as 1000, right? So since 1000, we can say its weight is 1000, and the next digit we say it as 200, right? So 200 means, forget about 200 is the weight of 2, and the next 30 means 3 into 10, we can write it as 3 into 10, right? That 10 becomes the weight of 3, and 4 becomes the weight of 4 will have a weight of 1. And remember, this one also can be written as 10 power 0, and like that. So this is how the digits in a decimal number system will have different value based on their position. Okay, and coming to our next slide. Okay, here it is. So in the same example 1 2 3 4, 4 is called as least signifying digit, and 1 is called as most significant digit. Okay, so that you try to understand. So that means this 4 will have the least value, that means its position value is 1, right? And hence we call it as a least significant digit. And 1 will have a weight of 1000, which is higher, right? And hence we call it as 1 is called as most significant digit. Okay, so that's it. I hope it is clear. Similarly, if you take one more example here, can you see this? I hope you can see this. This is 1 2 3 4.56, right? So that means this point, the digits that are present on right side of this point are the fraction values here. Okay, and so how can we write this entire digit which is in the form of a fraction in terms of 10 powers. So I hope you know this one. So we start from 4 here. So 4 multiplied with 1, right? 1, since 4 is in units position, let me take the marker now. So this is units position. Units position, that means its power will be 1. Its what do we say, its coefficient will be 1, and 3 is in tens power, and hence its coefficient will be 10, and 2 is having a coefficient of 100 or multiplication factor you can say, and 1 is having a weight of 1000. And since these are all greater than 0 values, greater than 1 values, we can write it like this. But what about 5? So 5 is the digit that is present after the fraction, right? And hence its weight I can write it as 10 power minus 1. So that you try to get it. And the 6 I can write it as 10 power minus 2, and so on. It moves. Okay, if there is one more digit, say 7. If 7 is there, its weight becomes 10 power minus 3, and so on. So remember, whatever the weight of this decimal number, that can be represented in terms of 10 powers. Like you can see here, it becomes 10 power minus 2, 10 power minus 1. Its coefficient is 10 power 0. This is 10 itself. This is 100. 100 means you can write it as 10 square, and 1000 also can be written as 10 cube, and so on. Okay. So anyway, let us move on to our next slide. So this is how the decimal number system can be written. Remember, we can write the any number in the binary system also. But before moving on to the binary system, this is binary number system, right? Before moving on to the binary number system, let us recall how do we write the numbers in decimal number system. So you may be thinking that we know how to write the decimal numbers, but remember, we are learning how to write the decimal number system right from our childhood days, right? But unfortunately, most of you don't know the logic of writing this decimal number system. Why we write and how we write, that I will discuss here, because that means if you understand this decimal number system, the logic of writing the numbers, you automatically will understand how can we write the binary numbers in case of binary number systems. Okay, so anyway, let us take a marker here. So you know that decimal number system will have 10 basic digits. 10 basic digits, you know them, right? These are all the 10 basic digits that this decimal number system has. What are they? One is 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9, and so on. So these are the 10 basic symbols or digits that the decimal number system has. So now how do we write numbers? You know them, right? So it starts with, actually we won't consider 0. You automatically start 1, 1, 2, 3, 4, 5, 6, 7, 8, 9. Then next 10, you call it as 10, 11, 12, and so on. You can write infinite number of decimal number systems. Okay, but how do we write it? That you have to understand here. So while writing the decimal number system, what the logic that in general we use is that we take 0 first. What we do, this is the first digit that is present in decimal number system, right? This is the first digit, so we take 0 now. So I have taken 0. So by taking 0, we write all the combinations. This is the logic that you have to understand. So that means I have taken 0 now. So this is the 0 I have taken, right? So by taking 0, you have to write the combinations of 0 with all the other digits. So what are the combinations that you get now? So with 0 the combinations will be 0 0 and 0 1. So remember, this is my 0, first digit that I have taken. So with the combinations of zeros become 0 0 0 1 0 2 and 0 3, and so on. It continues 0 4 0 5 0 6 0 7 0 8 and 0 9. There ends the combinations that you can write with 0. Okay, so in overall you get 10 combinations here. So I read those combinations even here also. So we have write 0 0 0 1. Let me take the other combinations also. This becomes 0 2 0 3 0 4 0 5 0 6 0 7 0 8 and 0 9. That's it. That means I have written the possible combinations that we get with 0 here. So 0 combinations I have written, but you know that 0 0 is nothing but 0, 0 1 is nothing but what, 1, 0 2 is nothing but 2, and 0 3 is nothing but 3, and it is nothing but 4, and so on you get. So how many you get? So you get up to 9. But actually this 1 2 3 4 5 6 7 8 9, these are the decimal numbers that you get when you write the possible combinations of decimal number systems with 0. Okay, so that you try to get it. So fine, so 0 combinations are over. Okay, let me erase everything. So now 0 combinations are over, and 0 combinations we got it here in the first column. So these are the 0 combinations that we got, right? So now since 0 combinations are over, forget about 0 combinations now. Now take 1. So can you see this? This is 1. So with 1 you have to write all the possible combinations. What are the combinations that you get? 1 0 becomes 1 0. Next 1 1 1 1. Next 1 2 1 3 1 4, and then next 1 5 1 6, and next 1 7 1 8 1 9, like that. The combinations that are possible with 1 in case of decimal number system, we get from 1 0 to 1 9. So this is how we write. And now I think and I hope the logic is clear to you. So how do we write the other numbers now? Now you take 2. Okay, so with 2 you write all the combinations. So what do you get? You get 20 21 22 23 24 25 up to 29. Similarly take 3 now and write all the possible combinations. You start from 30 and ends on 39. And similarly you take 4, and if you write the combinations you get from 40 to 49. So this is how we write the numbers in case of decimal number system. But without knowing, what we do is that we just keep on writing, right? That's it. We practice many times how to write the decimal number system, and we blindly write the numbers. But actually this is the logic by using which we write the decimal number systems. So like that, next what happens, we take 5. Even with 5 we do write the possible combinations, which you get from 50 to 59, and then next from 60 to 69, and from 70 to 79, and 80 to 89, and 90 to 99. So that means you have taken all the possible combinations. You have written all the possible combinations with the basic symbols that do exist in decimal number system, right? That's it, over. So 0 possible combinations are over, 1 combinations over, 2 combinations over, 3 combinations, 4 5 6 7 8 9 combinations are over. Next combinations will start from which number? I hope you are getting here, right? So please check it out. So this is 0, okay, that you got. So these are all the combinations that you write with 0, right? So these are all the combinations that you write with 0. So that means 0 combinations are over. And the next 1 combinations are where? So this 1 combinations start from 10, and 2 combinations start from 20, and 3 combinations also you have written here, and 4 combinations you have written over here which start from 40, and 5 combinations you have written over here, and the next 6 combinations also you have written over here which start from 60, and 7 combinations also you have written over here start from 70, and even 8 combinations we have written over here which start from 80, and 9 combinations also we have written over here which starts from 90. Then next number will be the 10 in the decimal number system, that you have to understand. Okay, so this is the logic. So now with 10 you have to write all the possible combinations. So the 10 combinations will be 10 0, 10 1, 10 2, 10 3, 10 4, 10 5, 10 6, 10 7, 10 8, 10 9. But these 10 0, 10 1, 10 2, 10 3, 10 4, we call them as 100, 101, 102, 103, and so on up to 109. So 109 means what? You have written the combinations of 10, the possible combinations of 10 that you get in case of decimal number system, you have written over here. So that's it, right? So where is that? Here. So this becomes the combinations of 10 now, and the next combinations will start from 11. That's it. They start from 11. What do you get? So please check it. 11 0, that means 110. After 109, what do you get? After 109 you get 110, right? And this 110 you get it from 11 combinations you have to write over here, and so on. Next 12 combinations gives you 120, 121. Next 13 combination, 14 combination, and 19 combinations gives you from 190, 191, 192, and so on up to 199. So once 19 combinations are over, which gives you 199, the next 20 combination starts. So 20 0 means 200, 21 means 201, and so on. And likewise all the numbers you continue. It's a chain process. It's like a chain process. If you write, that means if you write the combinations of a 0 with all the digits, you got up to 9, right? Next 1 combination to 9 combinations, you got it up to 99. Similarly 10 combinations, 11 up to 99 combinations, you get up to 199, and 29 combinations up to 299, and so on. It continues, and you can write any number that you want by using that means decimal number system. The thing that you have to understand here is that we blindly learned how to write the decimal number system, but actually there is a logic why we are writing the decimal number system in a particular order, and that logic I am trying to explain here. I hope it is clear. Okay, so in our next class, so this is a decimal number system, right? So if you have understood what is the decimal number system and how we write the numbers, in our next video or class, we try to understand how do we write the binary number system with the same logic that we used in case of decimal number system. Okay, I hope it is clear. We will stop here, and we will meet in our next video. Okay, thank you.